Welcome back to The Explainer. So today, we're unraveling a pretty wild digital mystery hidden deep inside Haskell programming. It's one of those situations that perfectly shows how the absolute tiniest detail, literally invisible, can trigger a massive ripple effect in the software we use every single day. We're looking at a case where a standard code cleanup somehow turned into a bizarre formatting disaster for an entire language group. Grab your detective hats, let's jump right in and solve this bug.
Meet the ideographic postal mark circle. Looks like a pretty simple circle, right? Well, keep this exact symbol in the back of your mind because it's actually the prime suspect in our mystery today.
Now, what's really interesting about this is how exactly does nothing, like a literal blank invisible space, suddenly transform into a giant, highly visible circle smack in the middle of a text document? Honestly, it sounds like a terrible practical joke. But in programming, it really comes down to pure, unyielding logic. Logic that, well, in this specific case, went hilariously wrong.
Okay, let's dive into this. Back in July of 2026, a developer named Ang was refactoring some Haskell code. And it was completely well-intentioned, right? They successfully reduced the lines of code, they got that faster mapping. But you know how it goes in the complex world of software engineering? You pull one string, and another one completely unravels. This noble quest for speed and efficiency accidentally set a completely invisible trap.
To understand the motive behind this bug, we got to look at how computers handle text, specifically converting standard single-width characters into the wider double-width characters used in CJK. That's Chinese, Japanese, and Korean formatting. To make the code run faster, Ang applied a neat mathematical shortcut called a uniform offset. Essentially, they took an entire continuous block of standard characters and uniformly added a specific hex value to them, 0xFEE0. The goal was to just mathematically shift all of these characters into their full-width versions in one swift move, which honestly is a brilliant shortcut, assuming, of course, that every single character in that block follows the exact same mathematical rules.
And this brilliantly illustrates the exact moment things went sideways. The standard space character got caught up in that sweeping uniform math. When you take a standard space and add that uniform offset of 0xFEE0, the math simply doesn't land where you want it to. The code expected to land on hex 3000, which is the correct invisible, full-width CJK space. But the math actually resulted in hex 3020. And guess what lives at the digital address of 3020? Yep, you guessed it, the ideographic postal mark circle. The crazy thing is, the code didn't actually fail. It did the math flawlessly. It just mapped to the completely wrong destination.
Now, you might be thinking, all right, so the math was off by a tiny margin for one single character. Is it really that big of a deal? Let's step away from the dry hex math for a second and look at the real-world impact. Why does messing up a simple space matter so much, especially to folks reading CJK text?
So the crucial point is that the cultural and typographical stakes here are surprisingly high. In CJK formatting, and specifically in things like Chinese novels, the single-width space character is absolutely everywhere. It's not just used between words like we do in English, it's structural. There's a standard convention for paragraph indentation in these novels that relies on using exactly 4 single-width spaces to perfectly simulate the visual length of 2 double-width characters. It creates this beautifully aligned, traditional reading experience. So imagine opening a stunningly typeset novel, and instead of a clean, invisible indent, every single paragraph kicks off with a row of giant postal mark circles. The entire visual flow of the book is completely wrecked, all because of one tiny mapping error.
Let's move on and see how this builds to a solution. Take a look at the original buggy code's range. It started with that invisible space character, applying the math to everything from the space onwards. The fix here is as brilliant as it is simple. Just yank the space out of that uniform sequence. By shifting the mathematical range to start at the exclamation mark, literally the very next character after the space, the rest of the mapping works perfectly. Then Ang just hard-coded the rule for the space right above it. They explicitly told the program, hey, when you see a standard space, turn it specifically into hex 30,000. Boom, no uniform math required for the space, just a direct, correct translation.
But Ang went one step further to guarantee the formatting was absolutely bulletproof. During the parsing phase, they implemented a really clever workaround. Step 1, the program actively strips out all the leading and trailing whitespace from the paragraphs entirely. Then, Step 2, it completely sidesteps the single-width space problem by directly injecting the correct double-width CJK spaces right back into the paragraphs for the indentation. So even while they were untangling the messy mapping logic we just looked at, the actual use case, the formatting of those Chinese novel paragraphs, stayed perfectly intact and beautifully formatted.
It's just truly fascinating, isn't it? A routine quest for slightly faster code accidentally lays bare the strict, unforgiving mathematical foundations of typography. And it really forces us to ask, if one single line of well-intentioned code can literally turn empty, invisible space into a giant physical circle, what other invisible bugs are quietly hiding beneath the surface of the apps and websites we use every single day? The digital world we all rely on is built on these incredibly fragile, hyper-precise foundations. I hope this explainer gave you a deeper appreciation for the hidden complexities of coding and just how massive an impact the smallest digital details can have. Keep questioning how things work behind the screen, and thank you so much for exploring this with me today.